So the final video from Chapter 8 is about mechanical energy and the conservation of mechanical energy, which is Chapter 8-6 in the textbook. Okay, so mechanical energy. So remember, if you define a system, so a system is just a collection of particles or objects. And another important definition is you can define a system to be isolated. So in an isolated system, what that means is that the system doesn't exert a force on its surroundings and its surroundings don't exert a force on it. So in other words, you don't have any net forces coming in from outside your system that influence the objects inside your system. Or another way to think about it, so for an isolated system, you have zero net external force. So you only have internal forces between the particles or objects in your system. So mechanical energy, which we're going to use a capital E to stand for mechanical energy, is just the sum of kinetic and potential energy of the system. Okay, so in E, right, so mechanical energy is capital E, kinetic energy is K, and potential energy is U. And although it just says U here, so remember we've talked about gravitational potential energy, we've talked about elastic potential energy, so you have to add in all the mechanical energy, or all the potential energy of your system. So in principle, you could have both elastic and gravitational potential energy. Okay, so now we finally get to the main idea, or the most important idea in Chapter 8, which is the conservation of mechanical energy. So the principle of conservation of mechanical energy says that if only conservative forces are acting, then the mechanical energy of an isolated system is conserved. So, and there's lots of different ways you can phrase that, or write it as an equation. So you could say that the change in mechanical energy is zero, or you can write it that the initial kinetic plus the initial potential energy equals the final kinetic or the final potential energy, or delta K plus delta U equals zero. So these all really mean the same thing. So the important thing is that the mechanical energy of your system stays constant. It doesn't change. So if you look at it at any 2 points, the total mechanical energy is always going to be the same. But remember, there's a condition there. So a couple things have to be true. Only conservative forces need to be acting, and your system has to be isolated. However, this is really a fundamental principle in physics, the idea of conservation of mechanical energy. And in fact, usually what physicists do, if it ever seems like energy isn't conserved, they start to invent stuff to make it conserved again. So, and again, so just remember here, so mechanical energy in general is not going to be conserved if you have non-conservative forces. And remember, non-conservative forces are typically these dissipative forces like friction and air resistance or other drag forces. So, or if your system is not isolated, right? So if you have some external force acting on your system, in general, the mechanical energy is not going to be conserved. And we'll do several examples of this in class to see how exactly this works.